Hello everyone. So let's solve one more problem in the linear programming modeling and solution. So this is one example problem. Sorry for the quality of the print. I could not find a better image, but then you can just pause the video and slowly try to read the question, and then we can try to solve it. Okay. So this is the question, and you can just go through this question. If you're already want to if you want to attempt it, please do it. Now I'll be solving it. Okay, so let's start. So I'll write the answer here. So let me choose a different pen, or maybe, yeah. So Lakeside Boatworks is planning to manufacture three types of molded fiberglass recreational boats: fishing or bass boat, ski boat, and a small speed boat. Okay, so there are three products. Okay, so what are our products? Let's call it bass boat, and let's denote it with x1. And then next one is ski boat. Let's denote this with x2. And the third one is speed boat. Let's denote this with x3. Okay, so we have three unknowns, three products: x1, x2, x3, number of speed boats, number of ski boats, and number of bass boats, whatever, this three. Now, the estimated selling price and variable cost of each type of boat are summarized in the following table. So we are getting variable cost and selling price of each one. Okay, so we will come to it later. Now, the company has incurred the fixed cost of two eight, I mean 2,800,000, okay, or 2,800,000 dollars to set up its manufacturing operation and begin the production. So a fixed cost is given, and Lakeside has entered into agreement with several board. Okay, we'll come back to that. So now, what is the let me just write down that one: fixed cost. Okay, $2,800,000. Okay, so we'll come back to this. Maybe this will become one of the constraints. Okay, we will see. Lakeside has entered into agreements with several boat dealers in the region to provide minimum of 70 bass boats, 50 ski boats, and 50 speed boats. So the minimum requirement is given. Okay, that means I can write that as a constraint here. So bass boats should be minimum 70. Therefore, x1 should be greater than 70, greater than or equal to 70. 50 ski boats. Okay, so x2 should be greater than or equal to 50, and x3 should be greater than or equal to, again, 50. Okay, so these three constraints clearly we can mention from here. Alternatively, the company is of unsure of what actual demand will be, so it has decided to limit the production to no more than 120 of any boat. Okay, so any type of boat should not be produced more than 120. Okay, so therefore x1 should be less than or equal to 120, x2 should be also less than or equal to 120, and x3 should also be less than or equal to 120. Okay, so these three also we got it. The company wants to determine the number of boats that it must sell to break even while minimizing its total variable cost. Okay, so clearly it is given minimize the variable cost and achieve the break even. Okay, so what is break even? At break even, profit will be zero. Okay, so what is the profit? So first, let me write the variable cost. Okay, so variable cost equal to, so here for each product the cost is given. So I know the production x1, x2, x3. So therefore, if I take like this: 12,500 into x1, 8,500 into x2, 13,700 into x3. Okay, so let me write that: 12,500 x1. Let me just adjust the camera a little bit. Plus 8,500 into x2 plus 13,700 into x3. Okay, so this is what is the variable cost. Okay, so basically I have to minimize this variable cost. Okay, so I will write minimize. Okay, it came as mini and mice, but it is minimized. Okay, so we have to minimize this. Now, what is the profit? Profit is cost minus sales revenue. So, what is cost? Fixed cost plus variable cost minus, I'm sorry, the cost will be minus. So, I will say, let me rewrite this. Profit is revenue minus cost. Okay, so what is the revenue? So, in this case, revenue is, so here you can see the selling price is given. Okay, so 23,000 into x1 plus selling price of ski boat is 18,000. So 18,000 into x2 plus 26,000. Okay, so speedboat is very costly, 26,000 x3. So this whole thing is the revenue. So revenue minus fixed cost, that is 2,800,000. Okay, minus variable cost, whatever the same variable cost I will write here, 12,500 x1 plus 8,500 x2 plus 13,700 x3. Okay, so this whole thing is the profit. Okay, so now one condition is given here. The company wants to determine number of boats that it must sell to break even. So break even analysis. So break even means at the time the profit will be zero. After that the profit starts becoming positive. Okay, so this entire at break even profit equal to zero. Okay, so at break even profit equal to zero. So therefore, this whole thing should be equal to zero. Okay, so that is the condition. Okay, so now I have everything I have. Okay, so what I have, I think I read all the data and everything we have used. I have the objective function. Then I have one equality constraint, and then I have some inequality constraints. Okay, but for the ease of understanding, let's write it once again in a neat way. Okay, so formulation of linear programming problem. Okay, so let's once again do the formulation. So here I have to go for minimize. Okay, so what I have to minimize? Same thing. Just I will repeat the same thing. I'm sorry. 12,500 x1 plus 8,500 x2 plus 13,700 x3. So this is what I have to minimize. Then subject to constraints. Okay, what are the constraints? So I have six constraints clearly explained here. So let me write that. Okay, so x1, x2, x3, x1, x2, x3. So first it should be at least, so minimum production. Okay, that is 70, 50, 50. Here we have already written. So 70, 50, 50, and then maximum production is 120, 120, 120. So x1 should be less than equal to 120, x2 should be less than x3. So this is the constraints on the number of boats to be produced. One more final equality constraint I have, that is this one. So let us simplify this. Okay, so let us simplify. So how do you simplify? See, 23,000 x1 is positive, then minus of 12,500 x1. So these two I can subtract to get the final x1. Okay, so let me show that to you. So let me open the calculator. So here if you see, if I do variable cost minus selling, that's what I have to do, selling minus variable. So here 23,000 x1 minus 12,500 x1. Okay, so 23,000 minus 12,500. So I'm getting 10,500. So let me write that here. 10,500 x1. Now coming to x2, 18,000 plus minus of 8,500. Okay, so that's what let's do. 18,000 minus 8,500. So 9,500 I'm getting. So this is again plus 9,500 x2. Similarly, third one is 26,000 minus 13,700. Okay, so let me do that. 26,000 minus 13,700. Yes, I'm getting 12,300. So plus 12,300 x3. Now all these things. Now the remaining minus 28, this 2,800,000, I can keep it this side or I can take it to the other side so that zero is there. So if I take it to the other side, then this whole thing will become equal to 2,800. So basically, this is the condition for break even. Okay, so this one. So this is an equality constraint. Let me add that equality constraint here. Okay. So again, for the neatness purpose, I'm just writing it here again. So what is that constraint? 10,500 x1 plus 9,500 x2 plus 12,300 x3 should be equal to $2,800,000. So this is the minimum production, minimum production, maximum, maximum, maximum production. This is the break-even condition. That's it. So I have the entire linear programming problem. So let me draw a border around this. So this is the entire linear programming problem defined for this particular case. Okay. So now let us solve this linear programming problem using Excel. Yeah. So let me shift to Excel. So I am opening Microsoft Excel. So I go for a new file. So this is a completely new file. So now, just to be safe, I'll save this file. Let's call this Lakeside. So slightly increase the magnification. Now let us formulate the problem. Okay. So how do I formulate the problem? So here you just have to, I mean, there are multiple ways of doing it. So different people have their different style, but ultimately we use the software to do this. So let us see. So here, what I want to do is I'll keep start with the title, Lakeside Boatworks. Start with the company name. So let's make it bold. Next, I go for minimize. I think okay, minimize. Now here, let me write production or products. Okay. So what are the products? The products are x1, x2, x3. That is x1, x2, x3. And in fact, let us give the name to these products. So, so here we have bass boat, ski boats, and speed boat. Okay. So bass, ski, speed boat. So these are the products. Okay. So these are variables. Now, what is the solution? So these three blocks, I'll go for filling with yellow color. Okay. So this is where we have to find the solution. Okay. So let me do center justification for all these columns. Now this right now I'll start with one. Okay, so one of each product I'm manufacturing. Now in this case now minimize variable cost. So for what are the coefficients of the variable cost? Okay, so again look at the problem statement. So here we have uh, 12,500, and 13,700. Okay, so that one 12,500, 8,500, and 13,700. So these are the variable costs. So finally, what is the cost here? So let me write the left hand side LHS. Okay, so what is the cost? So I need to multiply this with B5. So here I have to put dollar, then plus this multiplied by C5. Here I have to put dollar. So I hope you are able to see the formula how I am doing it. It's just simple multiplication and addition. But this dollar sign is used because I want to drag this down so that we will get this. Okay, so right now, if I manufacture one bass boat, one ski boat, and one speed boat, the cost is this much. Okay, so, but anyway, this we want to minimize. Okay, let's go with a green color because that is what I want to minimize. Next, what are the constraints? Okay, so let me write here constraints. So I have minimum production constraints x1, x2, x3. Okay, so minimum bass boats, minimum ski boats, minimum speed boats. So this is the name of the constraint. And here I'll give one, here I'll give one, here I'll give one. And then the left hand side will be uh, just copy this. I think I have to go for no fill. Okay. So here the formula is number of boats. Okay. So here if I give 10 boats, so I can see here it will be 10 like that. Okay. Now this should be less than or equal to, oh I'm sorry, minimum means it has to be greater than or equal to, greater than or equal to, greater than or equal to. And what is our minimum quantity? 70, 50, 50. 70, 50 and 50. Next, these are minimum constraints. Okay. Now what are maximum constraints? Maximum bass boats, maximum ski boats, maximum speed boats. So here again I will give one, and this formula left hand side I'll simply copy, and this should be less than or equal to, less than or equal to, less than or equal to, and then here I have 120, 120, and 120. So exactly whatever I have written here, same thing I have written in this case also. And finally, break even constraint. So what is a break even constraint? So look at the coefficients 10,500, 9,500, and 12,300. Okay. So 10,500, 9,500, and 12,300. Okay. So I save this file, and this also I will copy, and this should be exactly equal to 2,800,000. Okay. So this is the constraint. Now I have defined everything that I need. So this is the right hand side, RHS, and this is the condition. So now let me go for solving it. Okay, so I save this file. So go to data menu and then say solver, then objective. Okay, so here I'm selecting this green box, enter. Then minimum, I want to select minimization by changing cells. So I take this. These three yellow colored cells are our decision variables. Now constraints, add. So here I can add these three together, left hand side, enter. Then the condition is greater than or equal to 0. I'm sorry, greater than or equal to, and the right hand side is this three. So this is how I define three constraints. Next, the other three constraints again add, select this three. Now the condition is less than or equal to, go to the right side and then select this three and say add. Okay, I can add individually also. So now finally I will add the this one equality constraint. This left hand side and then equal, and then here this one say add. Now I can cancel this. So then I have all the constraints defined. So two, like of course this came in the second, but the order doesn't matter. So I have all these things. Now here I select the linear programming, simplex linear programming, make constraint variable non-negative. Okay. So now I go for solving it. Okay. So I hope you are ready. Solve. Solver found a solution. All constraints and optimality conditions are satisfied. Good news. So I go for sensitivity analysis and say okay. I'm sorry, it is showing some other sheet, but let's, yes. So here now you can see 70 bass boats you need to manufacture, 120 ski boats, and 75.2 speed boats you need to manufacture, so that you are meeting the constraint, and also you are meeting the other all other, satisfying all other constraints. So of course you cannot manufacture 75.2 speed boats, so you can just go for 75 speed boats, you can round it off. So the final solution. Yeah, so I think, and I go back to my this thing. So here I will write final solution from Excel solver. So I get x1 equal to bass boats should be equal to 70. Then what was that? 120 x2. So x2 equal to ski boats, that should be 120, and x3 equal to speed boats, that should be 75.2, or you can approximately round off to 75. Okay. So what is your minimized variable cost? So minimized variable cost is 2,925,285 dollars. Okay, so this is the minimized variable cost. Okay, so this is finally we got the solution. So now we also have the sensitivity report. Okay, so it just shows the different sensitivity. So but right now we will not we don't worry about discussing that. So that's it. So this is the question. We formulated the problem and we solved the problem. Okay. So thanks for watching this video. So if you like this video, please press the like button, and you can subscribe to my channel and refer this to your friends. Okay. So see you in the next video. I will try to solve more problems like this in the next video in the playlist. Thank you very much.